Hello, today we are going to be discussing constructive and destructive waves. To begin, constructive waves are two waves, A and B, that proceed towards each other on the same side of the plane. Upon meeting in the middle, the waves create a larger wave. This can be thought of as the summation of the two waves, or A plus B. After which, the single large wave separates into two smaller waves again, A and B, each of which continues moving in opposite directions. Next is the concept destructive waves. Destructive waves are two waves, A and B, that proceed towards each other on opposite sides of the plane. These waves meet in the middle and, due to their equal but opposite nature, cancel each other out. Because these two waves still exist and still have a velocity propelling them forward, they proceed past each other and in the opposite direction just like they did for constructive waves. In order to recreate this concept, some simple math needed to be calculated. We decided to use a rope with a density of 0.04 kilograms per meter and hold it at a tension of 2.99 newtons. We then were able to calculate the expected velocity of the wave speed to be 8.65 meters per second.
In this first example, constructive interference will be demonstrated. This 25-foot rope was manipulated on either side, creating visible independent forces in the form of a wave on each side. The two waves move toward each other on the same side of the plane. The two waves meet in the middle at this point and create a summation of the two waves, creating the maximum amplitude within this system. The velocity of these two waves propel them forward and past each other as the wave continues down the rope in the same plane in which they started. To demonstrate these phenomena better, we place cups over the midpoint of the rope to compare constructive and destructive interference. In this case, the summation of the two waves was too large to fit through the gap, causing the cups to collapse.
In this clip, destructive interference is apparent because of the interaction that is noticeable between the waves on the rope at the center specifically. Two pulses are sent down opposite sides of the rope from each end at equal forces. In destructive interference, we expect to see a 0 point in the center because the waves would cancel each other, making them equal and opposite at all points. In this demonstration, the 0 point is clear and can be found at the center of the rope system being used. After the midpoint, the two waves continue along the rope on opposite planes due to the original force. By using the cups in this demonstration, the purpose of the cups is to act as a structure that would be knocked over, given that the rope does not experience destructive interference. In this trial, the two waves from opposite sides of the rope meet in the center and cancel one another out, resulting in the standing cup structure. This is the method that was used to evaluate the way destructive interference results in the 0 points expected to occur in this system. Here is a different angle of the system, using the rope and cup structure in the center.